Hello, my name is Petri Heinonen. Here will be presented some workflow examples how Tekla Aveva PDMS link is used. First example is export from Tekla. Tekla model includes all kinds of objects and different materials like steel, concrete. User-defined attributes are used to define hierarchies, side joints through framework, subframework, which is used in PDMS side. Normal Tekla's user-defined attributes handling and defining in objects.inb are used. Start export to Aveva application. Using filters is best way to define objects to be exported, but also selection possibility is available. For example, for checking purposes. Hierarchy definitions can be also checked, and red color appears if something wrong or missing. Rows are related to model objects and so easy to select and find objects. In Aveva hierarchy text file is defined which UDAs mean which hierarchy definitions. UDAs and report fields can be used. And also if then else possibility is available because several rows can be defined. And if first row includes empty UDA, then go to next row and so on. When export is finished, then green color appears. More detailed information from export can be seen by pressing log button. Recommended way is to use only one PDMS site definition in one export file. So one export file from Tekla includes one site of PDMS and all other hierarchies below that. Result file will be imported to PDMS but can be imported also to Tekla. Defined UDAs hierarchy and others are included to objects and so also can be imported to PDMS. UDAs which wanted to be exported will be defined in Settings tab page of Export to Aveva dialog. Next examples are import to PDMS and handling updates, revisions from Tekla. First, start Tekla Interoperability and select imported file using dialog. In first import, objects are new and have green color, except objects which have missing or wrong hierarchy definition. Those have blue color and will be placed to unplaced hierarchy in PDMS. In this example, some objects have missing hierarchy definitions on purpose defined in Tekla side. Here site name is site XXX and different steel, concrete, MISC zone names for different material objects. Tekla zone with unplaced and deleted frameworks will be created and unplaced and deleted objects added there. Imported DC zip file can be checked using also, for example, Tekla BIM site. If a new updated export file from Tekla exists, then yellow row color appears in dialog, and pressing import update button, updated situation will be imported to PDMS. Different colors show status in PDMS. Green for new objects, yellow for modified, PDMS ID number remain, and so for example linked drawings remain. Red color shows deleted objects in Tekla side. Deleted objects are put to deleted branch so user can see and delete them later. Also, user-defined attributes will be imported to PDMS. In attribute mapping text file will be defined which Tekla attributes to be imported and to which names in PDMS. Next example is to export from PDMS and later import to Tekla.
This is a short example how to export IFC from PDMS. I have selected a site here that are shown with different zones and strews and so on. I open the dialog, go to export and add this entry. Entry is then added based on the selection in the Design Explorer. For mapping, I have set up some mapping here, but important to know that site zone strew is not mapped here. That is automatically done when doing the export. So the files is like this. Select the line and do the export. Open the folder where the files are located. You see now that we have one log file that contains information about how this has been doing. You see there is some justifications there that are not correctly mapped. So, and we have one file with timestamp and one without. That is the standard way this is coming out. If you now look at the file, This is now important. If we go to one of the items in this, this is the attributes that are exported, and it's two property sets that are important for you for the export. That is the PDMS common, that are built-in attributes that are exported, and this is always exported, and there's nothing you can basically add here. And here you see that the whole structure is the site, zone, screw, framework levels are put in, so they are already there. The PDMS structural is the attributes that you have set on your own to be exported in the attributes export file. So this is basically how that is coming out. So actually, very simple thing. The next thing then will be to import this and to Tekla.
Next example is import to Tekla using hierarchies defined in PDMS. Normal reference model handling commands used. With the inquire command can be seen which attribute information exported from PDMS, like hierarchies. With IFC object conversion settings can be defined which attribute information imported to Tekla native objects, like here hierarchy definitions. By filtering can be defined which objects will be converted as native Tekla objects, like here structural steel objects. Convert IFC object command used. PDMS hierarchy information is added to user-defined attributes in Tekla, like site zone, screw framework. UDAs are defined in Tekla using normal objects.inp definition. Then in Tekla, modeling detailing can be continued, and then export updated situation to PDMS using export to Aveva application. Aveva hierarchy text file defines which user-defined attributes to be used for PDMS hierarchy definitions. Comment mark // needs to be taken away in front of row. Check hierarchies is good to use for checking situation. Result can be checked also by importing result file to Tekla and inquiring objects. Hierarchy UDA is correctly exported. Next example is to use batch export in Tekla side using BIM Publisher application. For example, different versions can be used when defined in general settings. Scheduling is defined in Scheduling tab page. Different export types can be defined like PDF drawings, different export types of model. Also macros can be run before and after export. In this example, Aveva export will be done using different filters as all objects and phases from 1 to 5. Log information is displayed and result files written to defined folder.